Hello, dear students. Welcome to the channel and very welcome to this playlist in which we are discussing about the second chapter of instrumentation and sensors. Up until now, we have discussed about different type of instrumentations, different type of sensors. We have classified those sensors based on whether they are analog or digital. We have discussed about their applications in detail. We learned how do these sensors work. Then we have discussed about the uncertainty in the measurement. We have discussed about the errors, different types of it, and how we can eliminate different type of errors with different methods. And today we are going to discuss about the order and the methodology of the sensor installation. We have slight of the idea about sensor installation from our previous presentations, and we know what sensor installation exactly is. And by the way, if you have no idea about sensor installation and how the sensor gets installed, and this is I'm talking about in generalized term, so you can check out the video which we made on this channel a few days ago, in which we took a case study to understand of the sensor installation and sensor sighting in detail. So you can check out that video. The link of that video will be flashing on the top right hand side corner of your screen in the I button, so just click on it and it will take you there. And if you are interested in the playlist in which we have discussed about IS chapter 2, you can click on I button. You will find the playlist over there too. So just check out the playlist and the video both together. And now coming to our case, the order of sensor installation and methodology that we are going to see today with the help of multiple examples, a few of them. Okay, so first one is this spring loaded band which we are going to see. Then we are going to see the scissor jack band. So the sensor is installed using a mounting band, and I'm talking about particular this sensor. For different sensors we have different cases, but we are discussing this case today. Okay, so this mounting band is made up of stainless steel generally, and holds the sensor in its place within a pipe or a channel. So first one mounting band is a spring loaded band, which is the simplest of all the mounting bands, and the transducer is fixed to the band, and the band is simply sprung loaded into the circular channel or small culvert. And this is how a simple spring loaded band looks like. Next we have the scissor jack band. As you can see here, the scissor jack band is used for using a same method as spring loaded type band, but to give added support to the expander when we use it to firmly clap the band in the place. So here in this image that you can see is the scissor jack band. This was spring loaded band, and above that spring loaded band we will be using the scissor jack band. After that we have the rectangular channel sensor mount. So this rectangular channel sensor mount is used. This is used a scissor jack to place a force at one end of the band and securely fixing the other end of the band to produce an opposing force to ensure a firm grip is made against the channel walls. Okay, then now you know the equipments which we are going to use to place the sensor. But but how would you know where do you want to install the sensor, right? So for that we can take the help of different uh, application diagrams that shows us the best sensor location for a variety of typical installation sites. So let me take you to the sensor 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 diagrams. So in this, each of the diagram will show the velocity profile at a several point. which places where the sensor should not be located and where the sensor may not be recommended to be installed. But with a little information gathering, it becomes easy to understand where do we need to install the sensor. So as an outfall is a sensor which is used to locate the sensor at least 5 times the pipe diameter from outfall, and the velocity profile which will become distorted close to the outfall, making it difficult to obtain the accurate measurement. So this is how an outfall looks like. Then we have the low flow dam, which is at least 30 millimeter of water is needed for sensor to make accurate velocity measurements. And if the site frequently experiences low flow condition that may need it to be monitored, a dam can be used to raise that level. So here in the image you can see it. When a level is raised by this method for velocity profile, it will decrease, and it is important to maintain the good balance between two parameters and not raise the level too high that the velocity profile falls too low, right? Recommended minimum velocity is this application will be 50 millimeter per second. So it may also not be possible to use this method if the flow contains large amount of sediment or rags, etc. So again, in such situations, the velocity needs to be kept high and aids self cleaning. After that, we have the vertical drop or buffel. So there is a certain thing that a sensor should not mounted near a vertical drop of the buffel. Right? Locate the sensor at least 5 times the pipe diameter upstream level from the vertical drop, or 10 times the pipe diameter downstream. So the same location criteria should be used for sites within a buffel or obstruction in this channel. Then we have the 90-degree elbow or gradual curve. So if the sensor needs to be installed near a curve or elbow, then it should be placed at a nearly 5 times the pipeline diameter, right? Or or at a maximum level upstream. So either that or 10 times the pipe diameter downstream of the band we use it. And if these lengths are impossible, it may be necessary to install a form of a buffel to correct for turbulence and smooth out the velocity profiles. So that is your 90-degree elbow or gradual curve. This is how a 90-degree elbow or gradual curve looks like. After that, we have a 90-degree pipe junction or Y junction. So this 90-degree pipe junction or Y junction we use to locate the sensor away from any pipe junctions. And most ideal placement is an entry point downstream. So this is only possible, however, if one can be certain that no other entry points are met during the downstream pipe connection. But we have to place the sensor at least 5 times the pipe diameter upstream, or 10 times the diameter downstream, just like the previous case. And if the flow of the one junction is very high, again the buffel may be installed to control the profile, and this is how it look like, right? So you know about buffel now. Now you have to install the sensor. So you have to see how to assemble the sensor mounting equipment, right? And also you have to install that particular sensor at that site. So how will you do it? So one of the mounting equipments is the spring band. And here's the list of for the spring band. Here's the list for different mounting equipment which you are going to use. You might need a mounting band. You might need an open channel sensor, sensor mounting screws, cable tiles, cable ties. This will be the parts which you are going to use, and the tools which you are going to use is screwdriver, simple flathead screwdriver, and a wire cutter. Okay, or a nose plier we call it sometimes. And this is how you mount it. First you place the sensor on the bottom of the band as the image shows, and then place the sensor over the two screw holes that you are seeing, and then line the insert up, and using two M3 screws secure the sensor to the band as you can see in the image. Then you have to secure the cable. So starting at the bottom near the sensor, secure the sensor cable to the band with the cable ties, and running a cable ties through the pre puncture hole and around the cable uh, does this. So continue the cable tied cable up to the edge of the band, and then cut off the extra cable to this length as you can see here. Then you have to insert the band, of course. Now that you are done with the cable ties, you have to insert the band. First squeeze the two open ends at the band together so that the band folds to the diameter smaller than the pipe, right? Which pipe it is to be inserted into. And this can exercise can be made easier by clamping two ends together using a grip pliers. Then you have to insert the band into the pipe front of the transducer facing the upstream. Then you have to slowly release the grip pliers, and then you have to ensure the band fits the pipe wall flush. In case of the scissor jack band, what do you need? Here's the list of the parts which you might need. You might need the mounting bands. You will need the open channel sensor. You will need sensor mounting screws. Two screws you will need of M3 screws. Then you will need cable ties. Scissor expanding jack will be required, and two split pins will be required. And again we are using the same tools which we used previously, so I'm not mentioning that in detail. But plus except for the screwdriver and wire cutter, you might need a adjustable spanner here. In the case of scissor jack, you require a small spanner which is adjustable, and why we will see that when we discuss about the installation of it. So before installation, what do you have to do? You have to adjust the band again. This is a scissor jack band, so you have to adjust it one more time. So how do you do it? So first you have to adjust the band. uh, for that, first attach the sensor to the band as detailed, right? As detailed as possible, as you can see here. Then what do? You fit one pivot of the scissor jack through one of the holes at the open end of the band, and then the other pivot through the hole of opposite open end to the band, and then secure the pivot by fitting a split pin in the small hole situated on the side of each pivot point. After installing the band and scissor jack, rotate the scissor jack securing nut anti-clockwise to close, and hence reducing the diameter of the band. And then slide the band into the pipe, and then rotate the scissor jack securing nut clockwise. So this will begin to open the band, increasing its diameter, and will eventually securely clamp the band to the pipeline wall. And to calculate the band length for scissor jack, the formula is given here. As you can see, you have to take the multiplication of pipe diameter with pi, and then you have to subtract 50 millimeters from it, so you will get the band length which is required. So that was for scissor types. Then you scissor jacks, and now you move to the rectangular channels. For rectangular channels, mounting sensors can be either by using a pole or plate system, or scissor jack and band. So first, for pole and plate system, which parts you will require? So you will require top plate, you will require a pole because it would be a base. Then you will require a sensor mounting plate and sensor mounting screws, some table ties, and 8 mm through bolts. Tools which you are going to require will be the flathead screwdriver and wire cutter, same as previously. And then you will be assembling the pole and the mount plates. So how? So first locate and drill at least two 8 mm diameter mounting holes in the top plate. Then anchor the top plate to the channel side using 8 mm through bolts, and then attach the sensor to the bottom plate in the same way as mentioned earlier when we discussed about the mounting band installation. So it's pretty much similar to the mounting band installation. So what is additional here? You have pole here. So you have to fix the pole to the bottom and top plate, and you have to secure it, which might will look something like this. Now let's take the second case which we are about to discuss, the band and scissor jack rectangular channel. So the parts which we are going to use for band and scissor jack rectangular channel will be: first you will require a mounting band, you will require open channel sensor, you will require two sensor mounting screws, you will require around 20 cable ties, you will require scissor expanding jack and two split pins, and two 8 mm through bolts will also required here. Pay attention that we will require more cable ties and there will be more cable used for the band and scissor jack rectangular channel, and that is why we don't use that very often. Okay, because it requires too much material and becomes expensive a little, though it gives you better uh, better application compared to the scissor one, simple scissor one I mean. So then you have to assemble and fix the band. So in order to do that, first what you are going to do, attach the sensor to the band as we saw in the spring ball installation, and then put one pivot of the sensor jack through one of the holes at the open end of the band. In the next step, you are going to secure the pivot fitting a split pin into the small hole situated in the other side of the pivot. Then you have to face it upstream and then fix the open end of the band to the left channel. Okay, you can let me show it to you, it will be more clear that way. So after that you have to put it facing upstream and fix the other end. So you have to put it facing upstream and then fix the other end of the scissor jack to the right hand channel wall with the second through bolt. And in final step you simply rotate the scissor jack securing nut clockwise to expand the band. Okay, so what will it will do, clamp it will clamp into the channel itself. So this is how you install a sensor, and for this we have took one example. For different sensors, of course, you will be required different accessories, you will require different methods to install different sensors. So it is different for each and every sensor, and the steps which you will require to install a sensor may vary based on whatever sensor you are using and whatever application your sensor is serving, right? But basically, whenever you install a sensor, it should be simple enough, easy enough to mount, plus it should be mounted such a way that you can remove it very easily whenever required. Plus the place where you are installing the sensor, it should not be a complex place or should not be a place uh, which can affect a sensor in a bad way or which reduces the life cycle of a sensor or affects your equipment itself. Also the sensor should not be too far uh, from the measurement item which item the sensor is sensing. Plus you have to make sure the sensor which you are going to use is not broken or is working properly. And then once you diagnose all the tests on it, after only that you shall use that sensor for any kind of use, right? So we will keep today's class till here. The next lecture might will be the final lecture of this second chapter playlist, and then we might will move forward with the new chapter. So we will keep today's class till here. If you have any doubts or questions related to today's class or any other class, please mention that in the comment section below. If you have any queries or questions related to the channel or anything else, please mention that in the comment section below as well. And any kind of feedbacks, whether they are positive, negative, or anything, are always welcome. So please mention your feedback regarding the channel and the videos and playlists in the comment section below as well. If you have any suggestions for me, if you want me to make a video on certain topic, if you want me to make shorts on certain topic, please mention that in the comment section below as well. Also, I'm thinking about reducing the length of the videos so that I can make short videos and compress more content into it, so it would become more easier for you to watch. Because sometimes what happens, the watching video which is at 30 minutes long will become difficult, especially early in the morning when you're working, right? So I'm trying to make short videos, but not YouTube shorts, short videos, so that and trying to compress more information in those videos, which might going to be experiment from my end. So please mention your feedbacks regarding that as well, so that I can understand whether it is going to work or not, and I can put more work to it. So please please subscribe if you haven't already, and please turn on the notification bell to get the videos regularly. And if you have any doubts, mention that as well. I will be seeing you next time with the next video. Until now, until then, thank you very much for listening, and don't forget to watch, share, and subscribe the videos. We will keep today's class till here. I will be seeing you next time. Goodbye for now.